There are two kinds of channels. One, natural, and two, artificial. Artificial channels are used in various applications, among which are irrigation, drainage, water supply, flood control. The All-American Canal is the largest engineered canal system in the world in terms of discharge. It transferred Colorado River water from Imperial Dam near Yuma, Arizona, to the Imperial Valley near Calexico, California. The Indus Basin irrigation system is among the largest water transfer schemes in the world. It features 12 large irrigation canals linking the western to the eastern rivers of Pakistan. Other water resources related fields are 1. Hydrology, the study of water in the hydrologic cycle. 2. Hydroclimatology, the study of climate and the hydrologic cycle. 3. Ecohydrology, the study of hydrology and its support of neighboring ecosystems. 4. Fluvial geomorphology, the study of the form and shape of streams and rivers. 5. River mechanics, the study of the mechanical properties and behavior of rivers. 6. Sedimentation engineering, the theory and practice of sediment transport in the hydrologic cycle. 7. Bottomology, the study of rivers. The following are various names for engineering canals. 1. Canal, a long artificial channel, usually of mild slope, ground supported, either unlined or lined with masonry, concrete, or asphalt. 2. Flume, a usually short canal, supported above ground, made of wood, metal, or plastic. 3. Chute, a canal of steep slope, usually supercritical. 4. Drop, a very short chute. 5. Culvert, a covered channel of comparatively short length, which may flow partially full. A prismatic channel has a constant bottom slope and a constant cross-section. The channel section is normal to the direction of flow. A trapezoid is the most common cross-sectional shape. For an unlined channel, it provides bank stability. Canals built of stable materials such as concrete can be of rectangular shape. Triangular channels are used in ditches and roadside gutters. The depth of flow, y, is the vertical distance from the free surface to the lowest point in the channel cross-section. The depth of flow section, d, is the height of the channel cross-section, normal to the flow direction. The relation between depth of flow, y, and depth of flow section, d, is stage is the elevation of the free surface. Stage is also referred to as y, particularly when it cannot be confused with the depth of flow. The channel bottom elevation, with reference to an arbitrary datum, is referred to as z. Thus, the stage or water surface elevation is the flow area A is the area of flow of the channel cross-section. The mean velocity V is the average speed of the flow. The discharge Q is the product of mean flow velocity and flow area. The bottom width B is the width of the bottom of a rectangular or trapezoidal cross-section. The top width T is the width of the channel cross-section at the free surface. The wetted perimeter P is the length along the perimeter of the channel cross-section which is wetted by the flow. The hydraulic radius is the ratio of flow area to wetted perimeter. The hydraulic depth is the ratio of flow area to top width. Within a channel cross-section, the velocity varies vertically along the depth and transversely along the width. The velocities near the boundary are close to zero. This is referred to as the no-slip condition, the effect of friction along the channel boundary. Large velocity gradients near the boundary result in substantial shear stresses which entrain and transport sediment in unlined channels. Channel roughness has an effect on the curvature of the vertical velocity profile. A greater roughness produces a larger curvature. Maximum velocities occur near the surface at 5 to 25% of the flow depth measured from the top. In channel bends, velocities are larger on the outside of the bend and smaller on the inside. A hydraulically wide channel is that in which the ratio of top width to hydraulic depth is greater than 10. In a hydraulically wide channel, the sides have no influence on the velocity profile. In a hydraulically wide channel, the wetted perimeter is approximately equal to the top width. In a hydraulically wide channel, the hydraulic radius is approximately equal to the hydraulic depth. Most natural channels are hydraulically wide. In practice, a hydraulically wide channel can be approximated as a rectangular channel of depth D and width B. A unit width analysis is applicable in hydraulically wide channels. The discharge per unit of channel width, Q, is velocity measurements are usually made with a current meter. The Price cup current meter is in common use in the United States. Velocity measurements are made at point 2 and point 8 of the flow depth and averaged to obtain a representative value. For shallow streams, one velocity measurement at point 6 of the flow depth measured from the top is usually sufficient. The location of a stream gauging station is chosen carefully to minimize 1. Flow non-uniformities and 2. Shifts in stage flow rating which may be caused by changes in bottom roughness and/or erosion and sedimentation.